So this is the machine learning uh, part of it. And so you have actually two things. You have a training instance, and then in each instance, you have a training run. Um, and then that's kind of how the system works. So basically, when you hit yes, here's my data I want to train, it spins up a training instance, and then each instance can have many runs of training. And the point of that is during each run, you tune the machine learning parameters in different ways to get it to boost the accuracy.
So what is the thought process behind having multiple instances? Because if I understand it correctly, each instance is sort of starting from scratch, right?
Yep, exactly. And so, I mean, the biggest reason I designed it like that, where I could also tear all this down and redesign it if I learned something new. But the biggest reason I designed it like this is because because you can also, with new gathering runs, you can also get more data, and with more data, and data is heavily tied to the accuracy of your model. If you have bad data, then it's going to throw off your model. And so that's why, so you can get new data, you can train it again, you can queue more instances.
So you don't want to pollute like an existing instance with new data just constantly being added to it over and over and over again.
Exactly. And right now the system doesn't support data mapping, so it's not mapping what data it trained on yet.
Yeah, that's
but
hard.
that could be associated with the gathering runs. But I have all of the data like models there. I just need to combine them in different ways to get more interesting results like that.
Yeah, that's tricky though. That sounds like a giant headache to put together.
Yeah, it's fun though. I like the challenge.
So let's hop over into the actual some of the training code.
Yeah, so then we're gonna back out of the server. This is the more interesting thing that I want to talk about, in my opinion. But I'm just calling it a training service. And so the basic premise for this, what the training service does right here, is it basically sits around and waits. It doesn't care who's sending the data to it or what user is. The point of this service is to sit around and wait for incoming data, and it just tells it basically who's it. I guess backing up. So when the user makes a request to the server and they're like, I want to train my project, it then proxies this through a technology called Redis over to kind of like a queue system. It queues it over to a training service that's running, and the training service basically takes the top of the queue and then runs it, and it sends metadata over like who the user is, what project ID you're wanting to train, and then it grabs it here, and then trains your project with different parameters. And one thing I should note is I have a training runs.json file. Right now it's hard coded, but I only have one run added into here. We can take this. Right now it's hard coded, but so you have run 2, and then here's how you propagate new runs. It basically reads this file in, and then goes through these different parameters, and you can tune them. I also have an augmentation section. So you can do this, and this will augment your data, meaning it will create new images based off the existing data that you already have. Yeah, I'm messing this up right now, but you get the point.
Yeah. So we're running short on time here. Can we hop into some of the source code? I see that source file right there.
Yeah. So I guess the juice of it is right here. So it loops over all of your training runs that you define, spins up a trainer, and then it runs through the training process, and then stores the output for each run. And that's how you get the training runs. If you dig into the source directory here, I got some cool stuff. I got a trainer.
I was gonna say I want to see that trainer class.
Yeah, this is like, I'd say the main class for how this is like the training manager. That'd be a better definition of it. But it starts off the process here. You enter your data up here. Starts off with the image pre-processing step. Then I have a network factory, which builds the neural network based off of your data. Here you see it actually building it. Then a key component to this system is the data generators. Because you can't load all of these images into memory at once, and so you have to load them in batches. And so the data generators take care of loading the data into your neural net as it's training, and then also on the fly augmenting your data. So if you have a picture of a cat flipped left and right is the same thing, same exact thing of a cat, but it's changing the data and augmenting it to increase the accuracy of the model. And so it's doing that on the fly in the data generation process.
So are there any other ways you can augment it?
Yeah, I can actually go into the data augmentation pipeline class here. And so right now I just have a couple of them defined. You can add almost infinite amount of augmentations to it. I mean,
it'll affect flip left, right, flip up, down.
Yep. So so you can blur it. Right here I have a rotate random 25 degree. Flip left. Yeah, and so like all of this, and then here's the actual code, controlling that.
How much are you blurring it? Can you control that?
Yes. Yeah, that's actually a good question. You can control how much you blur it, whether it's just infinitesimally or even more. Right here, I have I'm starting at a range of 3, and it's kind of loosely defined. But I'm starting at a range of 3 and going up to, I believe, like 4 or 5. I'd have to look, but yes, you can blur it as much as you would want. I try to create it so I try to add it in here into an automated pipeline. So I didn't want it to blur it too much where it's like unrecognizable, and I didn't want to add too much randomness to it. So it basically blurs like 3 images or 4 images in a certain range.
So which of the augmentations, which one is the most difficult to pick up?
That's a good question. I don't know. It's pretty hard to test that inside of a neural network. And so like you only know kind of through your training runs and sort of so like for instance, a good way to test it is with with unseen data. So you're going through all your data, you're classifying it, and then you have data set aside completely separate, and then like let's say cats and dogs is like an arbitrary example, and then you have 100 pictures of cats, 100 pictures of dogs, and you randomize them in different orders or whatever, and then you have your model make a prediction and you see how many of those it got right. And so that's like kind of your ground truth, and so you don't really know how your augmentation is affecting it, and so you can tune different augmentations as you see fit. And that's kind of where I'm heading with this system, is I want it to auto tune the data augmentation as a reinforcement learning algorithm. So the higher accuracy it gets, it controls these different augmentation parameters along with the other hyperparameters in the training process.